All right. Thank you everybody for your patience as we got everything set up there. My name is Jonathan Simon. I'm the North America Residential Plumbing Manager for Lubrizol Advanced Materials, the manufacturer of FlowGuard Gold pipes and fittings. I wanted to talk today about something that's really close to a lot of us the last couple of months, which is the topic of frozen pipes. And really trying to get into why problems occur and what can be done from a construction standpoint to reduce the risk. So I wanted to just start out by saying, while freezing temperatures in Texas are rare, they are not that uncommon. In the last 100 years, there have been at least 9 severe freezes, so running on average about 1 per decade. And the 2021 freeze from Winter Storm Uri, from a purely weather standpoint, was not the worst of the freezes that have happened in Texas. This is just Houston. Obviously, the farther north you're going to get in the state, you'll probably see even more frequently than this. So whether it's going to happen again, whether that's in 2 years, 5 years, 10 years, it's very important that we start considering the impact of cold temperatures as we're constructing our homes and our broader infrastructure. So why do pipes freeze? Pipes freeze when they're directly exposed to temperatures below freezing for at least several hours. And the rate of freezing can be influenced by several factors, including how cold the air is, the water temperature. You may have heard that hot water freezes first. The thermal conductivity of the pipe, which is how quickly the cold transfers from outside the pipe to inside, insulation practices, and system design. So all of these can play a role. And when we talk about where pipes freeze, first geographically, frozen pipes can happen anywhere in the country, but you might be surprised to learn that frozen pipes are actually much more common in the southern states than they are in the northern states. And there's a few reasons for this. Number one, as you're very aware, unprepared infrastructure can lead to power and gas outages that amplify the effect of the cold temperatures. Obviously, this is what happened in February, and it led to a lot of major issues, including some fatalities across the state. That's not something that we can deal with necessarily from a home construction standpoint, but it is a backdrop to these issues. But other issues that do speak more directly into the home include things like building codes that are designed for warmer climates, which lead to inadequate freeze protection. And in some cases, contractors taking shortcuts, because when they're putting in their systems in 108-degree temperatures in the middle of August, they have already forgotten that it gets cold every now and then in February. So they'll do some things that they really shouldn't, and oftentimes it gets through the inspection. And we'll talk about some of those things later on in the presentation. And of course, homeowners who are just unaware of freeze protection practices at their home can also lead to some additional issues. In a house, pipes can freeze anywhere that the cold air can reach the pipe. So the question comes in, how does ice actually form within the pipe? A lot of people think that ice forms from the inside out, pushing outward on the pipe wall. But that's not what actually happens. When it gets cold, the ice actually begins to form on the outer wall of the pipe, and it expands inward, first pinching off the water flow before it completely blocks the line. Now, why do pipes burst when they freeze? Again, a lot of people think that it's actually the force of the ice pushing on the pipe, but that's not the case. It has to do with water pressure. So in an unfrozen pipe, when there's no water flowing out of a fixture, there's no additional water being drawn into the system. That creates an equilibrium that stays within the temperature and pressure ratings of the system. However, when ice forms, it does several things that directly affects the water pressure in the pipe. First, the ice plug acts like a closed valve. Now, this prevents new water from entering the far side of the ice plug, but it also prevents the trapped water from escaping backwards from the system. Secondly, as the ice plug starts to expand, it doesn't expand outwards, it expands laterally. So it actually forces the liquid water on the trapped size to squeeze and try to compress into a smaller piece of pipe. Because as we all know, ice takes up more space than the liquid water that forms it. So as the ice plug expands down the length of the pipe, it actually pushes the trapped water. And because water is incompressible, the pressure increases as the liquid water pushes outwards against the pipe wall. So as that ice plug continues to expand further and further down the pipe, it's trying to squeeze the water tighter and tighter. That water won't compress, it wants to go somewhere. So it starts increasing the pressure until eventually it exceeds the pressure rating of the pipe, causing it to burst. So let's talk a little bit about burst pressure. We know that the pipes are going to fail because the water pressure caused by the ice plug exceeds the rating of the pipe. There's two different kinds of ratings that pipes can have. One is a sustained temperature and pressure rating. This is what you're probably most familiar with hearing. It's the temperature and pressure rating of the pipe. It'll sometimes be printed on the pipe. It's what the manufacturers like to talk about. However, when it comes to freeze burst resistance, the most important factor is the minimum short-term burst pressure. And for the three most common materials used in Texas, copper is going to have a minimum short-term burst of about 3,000 to 4,000 psi. CPVC will have a minimum burst of around 1,250 psi. And PEX will have a minimum short-term burst of about 475 psi. Now you might be scratching your head and saying, wait a second here. That doesn't make sense. If copper has the highest burst pressure, why does it fail so frequently? And if PEX has the lowest burst pressure, why is everybody saying that it's a freeze-proof system? Well, the answer to this comes down to thermal conductivity and expansion. Now, it's helpful in a way to think about this almost like a horse race. So copper has a very high thermal conductivity, which means that the heat, the cold, is going to transfer from outside of the pipe into the pipe very quickly. So think about that as how fast the horse is racing. Now, the lines here are the burst pressure. That's going to be your finish line, the point at which the pipe bursts. CPVC has a very low thermal conductivity. So that means that the cold air is going to take the longest to penetrate through the CPVC pipe. It will still penetrate, but it's going to take the longest amount of time. But both copper and CPVC are not expandable systems. Whereas with a PEX system, the thermal conductivity is much lower than copper, but still about 3.5 to 4 times higher than it is with CPVC. But PEX is expandable. Well, now what that means is as the pressure starts to slowly build within the system, the PEX pipe will actually start to balloon up. And as it balloons up, it relieves some of that pressure. So it slows down the rate at which you're going to reach that burst pressure. So hopefully this will come through all right. This will be our first horse race simulation. And you can see the copper pipe bursts first because the thermal conductivity makes it run fastest. CPVC is going to burst second because, while the heat transfer is much slower, it's not an expandable system, so the line doesn't move. Whereas with the PEX system, it's going to move a little bit faster, but that line is also moving because of the expandability. Now, as I mentioned before, this is how the expansion protects PEX. Now, this is a photo actually of a just water pressure burst, not related to freezing, but the same principle applies. So when you have that water pressure slowly rising, it pushes on the PEX, and because PEX is an elastic material, it does expand or balloon out. The water then drops in pressure, preventing the burst pressure from being reached for a time. However, this does not mean that the system is immune to freeze damage, and there are some limitations of expansion. And we saw this back in February. There were a lot of PEX failures throughout Texas, and I'll show some of those photos here throughout the presentation, all of which were photos that came out of Texas homes over the course of the freeze a few months ago. This expansion has the limits. Number one, it needs room to expand. So the shorter that pipe run is between fittings, the less likely it's going to have the room to expand, the more likely it's going to be to fail. The fittings do not expand. So when you have that high pressure at the joints, you can get pullouts or cracked fittings depending on the materials and the design of that fitting. And one of the key advantages of PEX in the marketplace is its ability to be bent. However, when you bend PEX, you're putting some stress into that bend. And at that location where that stress from bending occurs, the PEX is less able to expand than when it's in straight length form. So that reduced ability to expand can result in more rapid failures at those points. And most importantly, all the testing, all the research, all the claims that are out there around the ability of PEX to expand has been done on brand new pipe. However, as that pipe ages in surface, after 5 years, 7 years, 10 years after it's been installed, the ability of the PEX to expand can drop significantly. So one of the reasons why that ability to expand drops is because of a chemical incompatibility between PEX materials and chlorine-based water disinfectants. So in the United States and in the state of Texas, nearly all water treatment facilities use some form of chlorine-based water treatment, whether that's standard chlorine, chloramine, or chlorine dioxide. These PEX systems are tested and shown to last under ideal conditions as much as 50 years, even with this degradation effect occurring. But that test only considers the rate of degradation and the chlorine basically chewing all the way through the pipe. What it doesn't take into consideration is the fact that even a very thin layer of oxidation can reduce the ability of the PEX to expand before breaking by as much as 90%. So the photo here, this is taken with a high resolution, high magnification photo. And this is of a piece of PEX that had been in service for several years. And it's a oxidized layer of 0.003 inches. Now that's very, very thin. You could barely see that with your eye. However, that thin layer of oxidation creates an inability for the PEX to expand, and therefore, when that pipe freezes, you get a slightly different dynamic than that ballooning that we saw before. When the oxidized layer tries to expand, instead of stretching out, it tears. And that tear might only occur in that thin oxidized layer, but the rest of the pipe, even though it hasn't been damaged by the chlorinated water, continues to expand normally. And in that expansion, it pulls on the torn and cracked oxidizing layer, causing that crack to expand through the pipe wall. And as you see in that graphic in the middle of the page, as that pipe wall starts to tear, it gets thinner. As it gets thinner, the pressure bearing capability at that point actually reduces. So what that looks like in the real world are these photos on the right-hand side, where you see that thin oxidized layer caused a micro crack. That micro crack started to be torn out as the rest of the PEX started to expand, and then you end up with this very thin layer of PEX remaining. And in the case here on the cold side, the pressure built to the point where that thin layer burst, and on the hot side, it came very, very close to bursting. So this is the dynamic at play. So let's take a look back at that horse race that we were talking about. Now here we've got copper, we've got CPVC, and now we've got new PEX and aged PEX, and we'll see how the different systems perform. Now you can see here, because the aged PEX cannot expand the way that new PEX can, the accelerated rate of freezing compared to a CPVC product, because of that higher thermal conductivity, actually leads to the aged PEX failing a little bit faster than the CPVC. Now you'll still see copper is still going to be the first to fail. And again, new PEX is still going to take a long time to fail. But that dynamic does significantly change as the system ages. So now that we've talked about why systems can freeze and why the different materials fail, let's shift over into how to really prevent those problems from occurring. So the first thing to remember is all systems will fail when frozen. Nothing is freeze-proof. Whether it's copper, CPVC, or PEX, your material selection or your contractor's material selection will make next to zero impact on the long-term risk of frozen pipe failures in your homes. It may have a lower rate of failure over the first couple of years, but down the road, even within the lifespan of that first owner occupancy, it is not going to make a significant difference on the long-term risk of failures. The only way to avoid frozen pipe problems is through good design and installation practices. So you may have heard whether it was the newscasters back in February when the freeze was coming, or maybe your grandparents, or maybe you moved from up north. You've probably heard somebody say, when it gets cold out, leave a faucet dripping to prevent the pipes from freezing. Now this can work, but not in the way that a lot of people think that it does. A lot of people think that you leave a fixture running because flowing water takes longer to freeze. That's not true. But leaving a faucet open can act as a pressure relief. So during a freeze, as that pressure starts to build, having an open fixture actually allows that pressure to escape the system, preventing all the problems that we just talked about. But it only works if you're opening the right faucet and if you have the right system design. So if you run a trunk and branch system, which is the design there in the lower left-hand corner, opening the last fixture in the home can, in theory, relieve pressure throughout the whole system, unless the freeze occurs in an isolated line. So hopefully you can see the cursor here. If you were to open, say, this fixture over here, it would relieve pressure from everywhere through this whole main line. However, if the freeze occurred at this point, or say at this point, the pressure could still build up in that short leg that doesn't have an open fixture, and you could still have a failure. It does reduce the risk, but it's not a foolproof system. However, a lot of builders, and I've seen this a lot in Texas, a lot of builders have gone to a manifold or home run system. Now, with a manifold system, each individual fixture has its own dedicated supply line. If you're running that type of system, opening up a fixture is not going to protect the whole system. It will only protect that one individual supply line, because that system isn't integrated with the other lines. So if you've got 18 fixtures, you'll have 18 different hot lines and 18 different cold lines. And each of those fixtures would need to be left open in order to relieve the pressure. So depending on your system design, running a faucet may or may not help to reduce the risk. And a lot of homeowners don't even know whether they have a home run system or a trunk and branch system. So when they see the evening newscast come on and say, hey, we got a freeze coming, turn open a fixture, a lot of homeowners might not even be aware that what they're doing isn't going to help. So now I'd like to talk about some of the installation practices. And I mentioned before some of the contractor shortcuts that can be taken. And this is a big one. You want to make sure that you avoid installing pipes outside of the conditioned space. So areas of concern would include uninsulated attics, crawl spaces, any cantilevers, jetties, or overhangs, and then any exterior walls. When piping does have to be installed in these areas, special care has to be taken that the piping is installed inside the conditioned space. And that means that the insulation, not the pipe insulation, but the building insulation has to be on the outside between the outer wall and where the pipes are. If you're relying on piping insulation, it's not going to be able to properly protect the system. Now, the photo over here, this is from a house that I walked probably 2 years ago, and this is a cantilevered ceiling, second floor overhangs, an outdoor living area, a porch, and they decided that they were going to put the bathroom in this space that overhangs the porch. So you've got water pipes directly installed in this open air ceiling. Now, unless they came in and they put good solid insulation into those ceiling joists underneath the pipes before they sealed off that roof, that would not be a conditioned space. The air that's used to condition the living area would not reach that area where the pipes are installed, and that would be a space that I would consider a very high risk for freezing. Now, you'll see this happen a lot on job sites where the contractors want to run their pipes and they'll put it into an area where either they're not thinking about freezing or they think that the pipe that they're using is freeze-proof, so they don't worry about it. And these are the areas where you're most likely to see problems arise. Another key issue, and this is really big throughout the state of Texas, is where you're placing the water heaters. I know it is very common in Texas to put your water heaters outside. So in this case, you have to make sure that the water heaters are inside the conditioned space. If they're in one of these containers, even if it's insulated does not equal conditioned. Insulation holds in the heat that's internal to the system, but it doesn't actually create any new heat. So unless you've got that water heater actively running, there's going to be no heat generated, and you're actually going to be inviting cold air to those pipes. And as the pipes start to freeze in that exterior space, it creates that pressure buildup that works its way into the home. And when you have a freeze that's that close to the source of the system, you can actually see that pressure build throughout the entire home, which creates a more unpredictable scenario. Going back, I see a question that came in about dripping all faucets. Would that relieve pressure for the home run or the trunk and branch? Yes. So if you were to open every faucet, it would serve as a pressure relief, regardless of whether you have a home run or a trunk and branch system. But you do have to make sure that you're taking into consideration that the hot and the cold lines are going to be different. So if you just drip the cold side, the hot's going to be more likely to fail. It won't be protected. If you just drip the hot side, the cold side won't be protected. So you wouldn't, in theory, need to drip all faucets and the hot and the cold side on all faucets. So a little less than ideal of a solution, but it would work. One other area that you could take a look at when it comes to how to install the plumbing. Sorry, there's just another question that just came in on outdoor water heaters. How can you protect an outdoor water heater? So really, the best thing to do is just don't put it outside. There's very little that you can do to protect it. If minimizing the risk, you drain the system, get all the water out of it when there's going to be a hard freeze. If you have some sort of an insulated box, it could provide some minimal protection. But when you're outdoors and it's 11 degrees outside, there's really nothing that you can do to protect that system. You can do some things to reduce the risk by taking the water out, but ultimately the best thing to do is make a correction going forward and find a better place to put those water heaters, because outdoors is just not going to be the right place to do it. If it's a temporary solution, if it's a temporary cabin, something like that where you're not going to be living there all the time, completely draining the plumbing system when you decommission it, that's going to be certainly a measure of protection. But each of these systems also has their own internal components, Each manufacturer is different, and I would defer to those manufacturers for their specific guidance. But generally speaking, cold air, extreme cold for prolonged periods of time, and any sort of outdoor water system is not a good combination. Another area that you can consider, and I will point out that this is something that varies in terms of code acceptance across the different jurisdictions throughout the state. But if you are in a jurisdiction that allows it, this can be a really, really great protection. Instead of running the pipe overhead in attics and ceilings, where it's more likely to be exposed to uninsulated areas or could be subject to freezing in the event of a power outage, you can consider putting the pipes beneath the slab. In those cases, the natural geothermal insulation of the ground provides additional protection against freezing. It's always going to be warmer underground than it will be above ground. This can also actually protect the pipes in hot weather as well, where if you've got pipes in an attic, you may have experienced on a very hot day, the cold water is running warm or even hot. That same geothermal insulation will also protect the pipes from the hot weather as well. Piping under slab also offers significant production schedule and cost benefits because depending on whether it's a 1-story or 2-story house, you can get between 50 to 90% of the hot and cold water distribution piping installed before the slab is poured. So you don't have trade conflicts, and it can be a lot easier. But again, check with your local codes because some cities don't like this practice. Some do accept it. I can tell you that across the country, there's the entire state of Florida does this all the time with no issues. So it is a common practice, but it is one that does depend on your local code officials' preferences. But when it comes to freezing, this does allow for an additional layer of protection. Again, if it's extremely cold, you're not going to be 100% protected. If it's 11 degrees for 10 days in a row, the ground will start to get cold, but you do have that extra layer of protection. Another very important one is insulation practices. And like I said before, insulation is meant to contain heat, not create heat. So pipe insulation is minimally effective at preventing pipes from freezing because it can only contain the heat already within the pipes. It does slow down the rate of cold air getting into contact the pipes. But again, if you're in a situation where you've got very cold temperatures for a very long period of time, it's not going to be protective. The key here is building insulation. So like I mentioned before, piping must be installed on the interior side of the building insulation. When you put piping in an attic, the insulation should be placed over the top of the pipes so that the pipes are closer to the conditioned space than they are to the unconditioned space. And another really common thing that I've seen throughout the state of Texas is mechanical rooms being placed in the attic. So you've got your water heater, you've got your air conditioning units, all of those things being placed in the attic. If you're doing that, you want to make sure that the mechanical space should be structured and insulated as part of the conditioned space. The photo here is one example of how to do that. There's a couple different ways, depending on where you're building, what your mechanical space looks like, and what your local codes require. But in this case, the idea is keep those mechanicals inside the conditioned space so that they're not going to be subject to that cold air coming in from the outdoors. The attic is designed to bring in air from the outdoors. That's the whole purpose of an attic, is to get that ventilation flow. Normally, that's a good thing, and it's what you're going to want to see. But when you have these extreme cold, it draws that cold air in, and if there is any piping or mechanical equipment located in that area, it's going to be at a very high risk of freezing. And then lastly, we talk about sealing all exterior wall penetrations. We know that wall penetrations are going to be common. You have to do it for dryer vents, fans, hose bibs, electrical and telecommunications inlets. There's lots of reasons why you're going to penetrate an exterior wall. But if these penetrations aren't properly sealed with adequate insulation, in some cases caulking is required, tape or whatever the right processes are, depending on the type of penetration that you're looking at. It allows airflow into the wall cavity. And any insulation that you have, if these penetrations aren't properly sealed up, it defeats the purpose of the insulation. It's like not locking your doors at night. You're allowing that cold air to come into that wall cavity. And when that happens, all the piping that's in that wall could be subject to the extreme cold. So just to conclude on that, there's some key takeaways. Just remember, even though it's unusual, it's not going to happen every year. There will be another significant hard freeze event in the state of Texas. Whether it's going to be next year, 5 years from now, 10 years from now, nobody could tell you. But it will happen, and it's important to be prepared. All plumbing materials can and do fail when they're frozen. And where with CPVC and copper, the freeze performance is not going to change over time. With a PEX system, you'll see newer, younger PEX is going to have much more freeze resistance. But as it ages in service, as that chlorine oxidation starts to occur within the pipe, the freeze performance changes significantly and can be reduced by as much as 90%. As you're going through that construction process, the choices that you make and the choices that your contractors make in terms of insulation and pipe placement are going to be critical factors that can affect the resiliency of that home. So I know it's hard, it's fresh in your minds right now. When it's August and it's 108 degrees outside, it's going to be hard to think back and remember, everything that happens when it gets cold out and the freeze effects. But it is important to remember those things, not just in the design, but really important in the installation practices to make sure that the contractors are taking those things into consideration when they're placing the pipe, when they're placing the insulation, to make sure that that home is protected when that next freeze happens. And now I really wanted to make that presentation educational. I know it's a very important topic for the state, especially considering all the issues. But I did want to take a moment to talk about FlowGuard Gold plumbing systems. Since 1959, FlowGuard Gold CPVC plumbing systems have been trusted by American home builders to deliver clean, safe drinking water. Our first installation actually was in 1959 in Michigan. Since then, we've become very popular throughout the United States in both single family and multifamily construction. We've got more than 12 billion feet of pipe installed across the United States, making our piping America's most proven non-metallic plumbing system. We've been around the longest, and we've got the longest track record. When you choose a FlowGuard Gold plumbing system, you're going to guarantee that that system is 100% immune to chlorine degradation. You're going to get improved water pressure because FlowGuard Gold fittings do not use any pressure reducing inserts. So you're going to get a higher water pressure. The material costs are actually considerably lower than PEX or copper systems. And thanks to a lower biofilm formation potential, you'll actually get cleaner drinking water out of that system. So I don't want to be a commercial here, but if you aren't using a FlowGuard Gold plumbing system today, I would encourage you to reach out to our expert piping system consultants. Names and contact information here on this slide for North Texas, Oklahoma, Arkansas, New Mexico, where you'll talk to Brad Pick, and then for Central and South Texas and El Paso, and then Louisiana, Carvel Gardner. They'll be your great resources. They can help you out, answer any questions you have around plumbing systems, work with you to train your contractors if they're not familiar with FlowGuard Gold already, and help you to make sure that you're getting the best plumbing system, and that your contractors are fully aware of all of the do's and don'ts as they're going through it, so that they don't end up accidentally overlooking something that can put you at risk. So with that, I'll open it up to questions. I do see one question about local jurisdictions that don't allow in-ground piping. Or what are the concerns for those jurisdictions? The number one concern that I've heard from code officials who don't allow in-ground piping is the idea of having joints under a slab. A lot of this comes back to, copper and things like that, where you put copper under the slab, and if the solder joint wasn't done correctly, there were some concerns. That's really the number one. And now with pecs being mechanical in nature, I think there's a lot of code officials who are concerned about having any sort of mechanical type fitting under the slab. So that's going to be your number one concern. Some are also concerned about permeation, leaching, or the effects that can happen when the slab settles. All the drainage pipe is already under that slab. So every now and then you'll see an issue where the slab settles and it does damage the drainage pipe. It's rare, but it can happen. So those are some of the underlying concerns, and why some jurisdictions that have more pronounced issues when it comes to settlement, they'll be more likely to be the ones who restrict it, whereas other areas where you've got more long-term stable ground, they're going to be more likely to allow it. Seeing another question, is there a difference in what you do for an outside tankless gas water heater versus an outside electric hot water system? So the key is really going to be the water in the system. The cold will damage the different elements of the mechanical components differently, and whether it's a gas or an electric, it's really going to come down to the individual brand that you're using, talking with the manufacturer and what their recommendations are. But when it comes to the impact on frozen pipes, it really is just going to come down to the water in the system. And if there's water in that heater, then your risk is going to be significantly higher.
Jonathan, we do have another question. Does PEX or CPVC have a better UV rating or resistance?
Yeah, that's a great question. So when it comes to UV, UV affects PEX and CPVC in different ways. So PEX systems contain antioxidants, which are designed to slow the rate of the chlorine degradation we talked about earlier. UV radiation from the sun or from fluorescent light bulbs or some other sources does cause that antioxidant to be consumed. So it actually accelerates the rate of that chlorine degradation. Different PEX also has different UV ratings. So you can actually look at that in the number that's on the pipe. The pipe will have a 4-digit code on it, something like a 5306 or a 5206. It's the second digit that you're going to be looking at. If the number is a 1, then you're rated for 1 month of UV exposure. If it's a 2, you're rated for 3 months of UV exposure. And if it's a 3, then you're rated for 6 months of UV exposure. Anything beyond that would result in at least a 21% reduction in the life of the system. With a CPVC system, the UV exposure does not actually affect the lifespan of the system or the pressure-bearing capability of the system. What it will do is it can cause discoloration, and it can cause a change in the impact resistance. So CPVC that's been exposed to UV for an extended period of time could be darker in color and could be more vulnerable to damage when it's struck by other objects.
Thank you. So another question we have is, does age affect the freeze break resistance of CPVC and copper like it does with PEX?
So the answer to that is no. It does not affect the ability or the resistance of a copper or a CPVC system to fail in terms of the time to failure. You may notice that the failure modes will look a little bit different in older systems than newer systems, but the time to failure is not going to be any different. So you might see a slightly more ductile failure in newer pipe and slightly more cracking in older pipe based on how that freeze occurs. But whether or not that pipe's going to freeze is not going to be affected by the age.
follow-up question to that is, do these changes only help with freeze resistance, or can they help with other elements of home performance?
Yeah, so they absolutely can. I alluded to a couple of changes or effects that it can have. Obviously, we talked about the underslab piping from a production schedule standpoint, from a cost standpoint. It can be a significant benefit if they'll allow you to do it. And then just generally, when you insulate the system, we all know it gets hot in Texas. And we talked about how when it gets really hot, you can have cold water lines actually running hot water because of that thermal conductivity. So if you keep the pipes in a conditioned space, you can actually reduce the risk of that happening as well. It also has benefits for energy efficiency. If your mechanical systems and your piping are in the conditioned space, it will reduce the amount of energy that it's going to take to heat up the hot water when you're in the colder months. And it can also have an impact on your overall heating and cooling costs by making sure that you've got proper building insulation.
And I have one more question from the audience. This presentation mentions that chlorine dioxide or degradation can reduce the freeze break resistance of pecs. How does the chlorine degradation happen in the plumbing system?
Yeah, so the chlorine, it speaks to an incompatibility. So you think about it like copper and steel. A lot of folks have heard that you don't want to put a steel hanger on a copper pipe because it causes something called galvanic corrosion. Everything's allergic to something. When you're talking about a PEX system, one of the things that PEX is allergic to is chlorine. So at a molecular level, the chlorine attacks the PEX and it starts breaking it down at a molecular level, causing that degradation that was shown in the earlier photo. The rate at which that happens can be affected by a lot of different things: temperature, pressure, the aggressiveness and type of chlorine that's in the water. So there's a lot of variables at play in terms of how quick that could happen. When you're talking about a copper system, you're going to see similar issues, not so much with standard chlorine, although it can happen at high levels, but with chloramine water disinfection, we see rapid corrosion in copper systems when you're using chloramine disinfectant. With CPVC, it's actually formulated to be immune to chlorine degradation. So both of the C's in CPVC stand for chlorine. There's really nothing that can be done in that chlorination process that would damage the system. Okay, I do see a question coming through here on the chat around how the CPVC system ages, and that's a great question. So a lot of folks I've heard that term brittle being used around PVC and CPVC, and so the science behind that is as the CPVC or PVC ages, it actually becomes more rigid. And as it becomes more rigid, the pressure bearing capabilities of a CPVC pipe increase. It becomes harder. But as a result of that, it does become very important that when you cut into the system, that you use the correct tools. We've generally, you're not going to see piping systems that are going to fail randomly because of this. If they were installed properly, you're not going to see a failure because of this aging process. But what does happen is you'll have service contractors going in to do a water heater change out, and they'll use the wrong tool to cut into the pipe. And when they cut into the pipe with that incorrect tool, it can crack or damage the system. And that's where the story around brittleness comes from. The system, as it ages, the service life does not reduce, the pressure bearing capability actually increases. It's just important that the service contractors who are working with it are aware of the proper way to handle that system and use the correct tools when cutting into it. And if they use the correct tools, there's almost no risk of having an issue. When it comes to the freezing component, again, CPVC will burst when frozen, just like any other material. And whether it's new or old, like I said, a newer system might have a more ductile failure. An older system might have more of a cracking style failure, but it doesn't affect the time to failure. So in terms of avoiding problems, in terms of water damage and things like that, it's not going to make much of an impact whether you have a ductile failure or a cracking failure. As long as that system is properly protected from freeze, that's really what's going to reduce your risk.
Okay, I think that's a conclusion of our questions. Thank you, Jonathan from FlowGuard Gold. Appreciated your valued information that you've provided, and it's very timely with everything that's happened in Texas this year already. Do you want to say the Sunbelt Builder Show registration is live currently? So if you are interested in attending, please check out the sunbeltbuildershow.com. And if you have questions for FlowGuard directly, both Carvel and Brad's contact information were added to the chat, and they can also get you access to this presentation afterwards. So thank you, Jonathan and team, for everything.
Thank you very much for having me, and I'm looking forward to getting back out there, getting back down to Texas. It's been a while since I've had good barbecue, so I need to get down there.
We definitely have a lot of barbecue.
That's for sure.
Okay. Thank you. Have a great day.